Okay, we have the last presentation that was not in the program. Is marine observatories match the Internet of Everything. Loïc, Lagadec.
Hi, everybody. Thank you for attending my talk. Although as you might have been preparing yourself for a social breakout, so it's cool to have all of you here. So it's my first time attending this. So first I might introduce myself. I'm a professor in computer science in Brest, France. I work at ENSTA-Bretagne, which is an institute with a very strong focus on maritime activities, ranging from tagging some mammals to underwater IoT systems and fleets of AUVs and this kind of thing. Okay, so let's go to my talk. This is a joint work, and this is a joint work with Charbel Aoun and Ciprian Teodorov. Charbel is working in an institution in the south of France. My talk is entitled Marine Observatories Match Internet of Everything. So this mustn't be taken as Internet of Things, right? IoT is something very well known, but IoE is something a bit different. So as Diksha mentioned this morning, there's a lot of changes coming. And there's a lot of changes coming from different perspectives. As an example, we have new technologies, AUVs, IoT, new users, new usages, some new constraints such as time to market, growing complexity, growing heterogeneity, sustainability, etc. And we need to be ready for that, so we need to anticipate all this. And the best way to anticipate it to set up models. But I mean, we all use models, right? Because models, they are just a way of speeding up computations, rising up the abstraction level, playing out scenarios without having to consider all the backside boring aspects. And one key issue here is we want to be able to make decisions. So we need to do it in a collaborative way. We need to be able to start to do it simple at first. But I think Mark mentioned that. Do it simple, then increase complexity, test, and refactor what you have. And you'll reach your milestones by yourself. You also need some metrics because you want to be able to measure something, and you want to be able to measure data quality, but you also want to be able to measure your software. Is my software efficient? Is my software energy efficient, consumption efficient, resource efficient? And this is key for simulation. You want to be able to simulate your models. So all these things lead to the notion of models. We need to define models. In my understanding, models are software models. So when you have a look at models, it's a way of combining different levels of abstraction. On top, on the left, what you see is, okay, I have a problem I want to address. On the left, I have some logical solution for that, while on the lower level at the left, I have some constraint, meaning reality, and then I'll have my allocated solution. So just to give you an example, looking at sea activities, you have a lot of different people involved. You have fishermen, you have sea watchers, you have institutions, and all these they have different objectives. So we have ways of making all this working together, and these ways are regulations. Now, if you have a look at something that happened, finding many dolphins dead on the seashore. Then we had something that was disruptive, and we had to allocate a new situation, a new solution. And the French court ordered a fishing ban for several months, as an example, right? So the issue here is to be able to set up metrics, to take reality as an input, and then to be able to play out scenarios, so that to make hypotheses and make a kind of domain space exploration for solutions. Then you'll have this opportunity to make decisions. And my claim, which is my first contribution, is that the Internet of Everything, it's a perfect mental framework for modelizing all this. So the Internet of Everything, it's based on 4 pillars. The first one is things, meaning it's reality plus sensors, collecting information, and then issuing data. We've been watching a lot of interest in fairness, data fairness, right? So you can have data from different levels of abstraction for different usages. Then you have different users, potential users. Can be scientists, operators, decision makers, end users, maybe the whole society. And what I'm mostly interested in is the fourth quarter, processes. Processes are the way all of these collaborate. And processes basically can be assumed to be frameworks or software, right? Which sensor issue, which data, which operator wants which data, and so on. But you need to get software to do that, and the software you have can be themselves described as this kind of framework. Now, when you consider models, you have 4 classical levels of abstraction. First one is reality, the second one is model, and the third one is meta-model. Each level conforms to the upper level, right? And the last level is meta-modeling, meaning it's a kind of meta-modeling language that allows to define meta-model. Just to have an illustration in a maritime context, you have sensors collecting data, then you have data metadata or common vocabularies. It's exactly a one-to-one pairing. Right? And what we do is we use Internet of Everything as M2 level, meaning it's a framework for modeling things. Our second contribution is we've taken a very well-known technical framework. It's a framework used by big players such as Thales, Airbus when designing a new plane. And we've adapted it to represent Internet of Everything. It's maybe I should have scaled it up a bit, but what you have is you have sensors, you have different new concerns, new concepts inserted in the model here. So this is a description of actors, business actors, etc. Then we have developed our Internet of Everything models to capture given use cases, and one of the use cases we've been considered is the model marine observatories with acoustic sensors, submarine acoustic sensors collecting data, then transmitting the data to floating repeaters so that to analyze the data and provide feedback through a web interface. So my sum up is, okay, Internet of Everything, it's a very, very convenient framework for designing marine observatories because we have these 4 pillars which are natural in this context. So it helps representing, informating, and information extracting and decision making. Now we have some ongoing works, obviously. We want to set up simulators, meaning our model should be executable. So we want to be able to play with our models and collect feedbacks. We want to decorate models with some new information, such as temporal information. Actions that last for a given amount of time, this kind of concerns. And we have model-to-model transformations, such as to be able to address, as an example, resilience by being able to balance computations for energy concerns, for whatever, between different fleets of sensors, subathetical sensors. So thank you for attending. I'm open to any discussion. I'm open to any collaboration. That's precisely why I'm here. So do not hesitate, please. And I also have a poster ready, so maybe it's another way to discuss.
All right. Sorry, I'm a little bit tired. I have to pass. It was a very long day. So thank you, Loïc, because of this last presentation that changed a little bit the perspective, but questions for... You are tired too. Come on. Mark, yes, it's your.
Thank you, and I might have misinterpreted your usage of the word model, but is any of this connected also to data modeling, and where does that fit in? Because that's an opportunity where I could find a way of connecting. Or are you talking about processing models and...
Models embed data plus behavior, and then you can focus on data, basically. Let's say adding types at last. But you can also focus on global behavior, meaning designing data flows plus frameworks for developing tools.
I'll have a chat.
Others? All right. I think we are just in time. So thank you very much.